In this lesson, we are looking at um, finding the formula to calculate the expected value of a continuous random variable. To make it a bit easier to understand, let's look at a case where our variable is not continuous but is a discrete variable. For instance, assume we have a die which has 5 faces, not 6 faces, 5 faces, and we throw this die for a number of times and record the result according to this table. So when the score was 1, when the die landed on 1, that happened twice. So we had 2 cases where the die landed on 1. 4 cases it landed on 2. 6 cases it landed on 3, and so on. Now if we add this frequency table, these frequency values, we will get 16. So that means we throw the die a total of 16 times. Now, to find the probability of a certain score, like what is the probability of getting 3 when you throw in this die, that will be equal to the frequency or the number of times that 3 has happened over the total number of tries. So in this case, for 3, that will be 6 over 16, which simplifies to 3 on 8. Or more generally, the probability of getting x when we throw in this die is the frequency of x, how many times that x happened, over cumulative frequency, which is 16. But what about the mean value, the mean of all the scores that we had once we were trying this experiment with this die? So how do I find my mean value? So you know that to find the mean value, we need to add all the scores and divide by the number of scores. So here I have 2 score ones because 1 happens twice. So rather than adding 1 and 1, I can say 1 times 2. And then score 2 happened 4 times. So 2 times 4 gives me the sum of all scores, which are 2. And 3 times 6 will give me the sum of all scores, which are 3. Then once I times each score by its frequency, then I can add them up. So each frequency times by score, add them up, and divide by how many scores you have. The number of scores you have is equal to the sum of your frequencies, because 1 happened twice, 2 happened 4 times, so we need to add all of this up, which gives us 16. So this way we can find the mean. So each score or each frequency times by its score. So 2 times 1, 4 times 2, 6 times 3, and so on. We add them up, then divide by the total number of frequencies, which comes to 2.8125. But also there is another way of arranging this large fraction. We could have written this as 2 over 16 then times 1 plus 4 over 16 then times by 2, then 6 over 16 times 3, 3 over 16 times 4, and 1 over 16 times 5. And now in this new way of writing, we notice that 2 over 16 is the same as the probability of getting 1, score 1. Or for instance, 6 over 16 is the probability of getting a score of 3. A score of 3 has a chance of 6 over 16. So basically what we are doing, we are timesing the probability of each score by the score itself. That's the probability, that's the score. That's the probability, that's the score. So each probability times by the relevant score, and then we adding them up. So we can write this as probability of x times by x, then their sum. That's another way of finding the mean. So the mean for a discrete set of variables is the probability of that variable times by the variable itself, then add them up. So far we discussed, we limited our discussion only to discrete variables. What if our variable was continuous like that? Here I have x, which is my variable, and I have px on the y-axis, which is the probability. So, for example, if I'm talking about the probability of x0, then its probability is px0, which is that much, whatever the length of this line is. So x0, probability of x0. Now, if I do the same thing that I did for a discrete variable, which times in probability by the variable itself, here I got to times px0 by x0 itself. Then I got to do this for all of these variables, which are infinite number of them, and add them up. But if you remember the concept of integration, that means finding the area under this curve. Sorry, it's not the area under this curve. It is the integral of x times px. It gives you the concept of integration. When you are adding an infinite number of variables, you can consider it as integration, as integration means adding. This integration sign itself is coming from S. It is an extended S, which is summation. Anyhow, so all you need to do, rather than having this sum, you need to do integration all the way from minus infinity to infinity, but inside that integral you have the same thing, probability times by the variable itself, or the score itself. Score times its probability. This could be an area itself, but not this area, necessarily this area. So all you need to remember is the concept of summation, addition, when it becomes continuous, can be considered as integration. Thank you very much for your attention.